In this video, we want to use the properties of logarithms to find the exact value of the following expressions. And we want to do it without using a calculator. Some of them are pretty straightforward. It's important you know your properties. So I'm going to scroll that down a little bit, and you can pause and try these without looking at the properties. And then I'll go over here and just go through the properties of logarithms. So in the list below, a, b, m, n, and our real numbers. We want a to be positive, not equal to 1. B has to be positive, not equal to 1. M and n have to be positive numbers. The log of a negative number is not defined. And you should have an understanding of what a logarithm is. So if somebody asks you, so let's say I ask you, what is a logarithm? In a couple of words, maybe one word or two words, what would you say? Well, the answer is a logarithm is an exponent. Here's your definition. Y equals log of x to base a means x is equal to. So here y actually represents the logarithm. What you're looking for, the log of x to base a is y. That's your logarithm. Means x has to equal to a to the y. And notice where the y is. It's the exponent. So here are some of the basic properties. Log of 1 to base a equals to 0 because a to the 0 is 1. Log of a, remember the exponent there on a, it's understood to be 1. So the log of a to base a is 1 because a to the 1 is a. Notice this one. A and the exponent is log of m to base a. Notice if the base here is a and the log of the base of the exponent is also a. So a here and a here, the answer is m. Now keep in mind, so if it's like, if you have 2, and then this is 2, and then this is 4, this base and this base are the same, the answer is 4. That's what this is telling you. Now that's not the same thing. If you have a 2 here, that's not the same thing. So in this case, you would have to use property right here. It says if you have the log of some number m to the power r, and the base is a here, you can take this exponent and make it a coefficient, and vice versa, going from right to left or left to right. Here it's not log of 4. Now what you could do, you could say, rewrite this using that property, and write this part of it here as 2 log to base 2, and bring this 2 over here as an exponent. That makes it 4 squared is 16. Now it looks like that property. Base 2 and base 2 here, that then is equal to 16. So you have to be careful how it's written. Log of a product to some base is equal to the sum of the logs. Pretty clear, straightforward. If you have the log of a fraction to base a, that's the same thing as the log of the numerator minus the log of the denominator to that base. And then m is equal to n implies that the log of m to some base a will equal to the log of n to that same base. And it goes both ways. That's what this arrow means. The left side implies the right side implies the left side. Then of course you have to change the base formula. And a regular calculator, graphing calculator, you'll have an ln function and a log function. So log to base 10 for log and ln log to base e. So this one's telling me that if I have the log of m to some base a, that will equal to some other log. You pick the base. So the log of m, pick the base b, equal to the log of whatever this base is, a, to that same base. And obviously the base you want to pick for b here is either e, the ln function, or log to base 10, because that's what you have in your calculator. Okay, so take some time to look those over. If you already know them, then hopefully you already finished the problems. Let's go over here to this one here, and let's look at these. So the first one, the log of 3 to the 71 power to base 3. These are the same. So as we saw in the properties, that's just going to be the same thing as whatever the exponent is. This base and this base are the same. The answer is whatever the exponent is. Now here for the second one, it's ln. That means base e. It's not written, but this is e here. That's c. So e and e, the answer is whatever the exponent is, -4. Number 3, 2 to the power of log 7 to base 2. This base here and that base there are the same. So just like we saw in the property, this is going to equal to 7. Then the next one, we have the log of 2 to base 8 is equal to the log of 4 to base 8. So again, using the properties, I know that when I have a sum of logs, I can write it as a product. When going the other way, if I have a product, I can write it as a sum. So in this case, using the properties of logs, this is the same thing as the log to base 8. We have 2 times 4, which is 8. And now I want to simplify this. The log of 8 to base 8 equals to what number? Well, 8 to what power gives me 8? Well, it's 1. So that's equal to 1. Now here we have a product for number 5. But it's log of 6 to base 2 and log of 4 to base 6. How do we take care of this? Well, let's see. We can leave the first one the way it is. Okay, leave that one the way it is. And then we could do some simplification if we had the base the same. So how can we get the base the same? This one has base 2. So one way to do it is to use the change of base formula and say, well, let's say we change the base to 2. Let's say this should be the log. Remember the formula, it's whatever this number is times whatever base you pick. In this case, I pick base 2. And then the denominator is the log of whatever this base is, in this case 6, to whatever base you picked. And I picked 2 here. Now again, log of 6 to base 2, that's just a number. Log of 6 to base 2 over here, that's this number. Okay, those, one's in the numerator, one's in the denominator, these divide out. Let's divide out. And this just gives me log of 4 to base 2. Don't need a calculator, just using the definition of log. The log of 4 to base 2 equals to what number? Well, what exponent do I have to take 2 to get 4? Well, 2 to the second is 4. So the answer is 2 for that one. Now let's look at the next one. It's 5, and then that's an exponent. So it's 5. And this is the sum here. So if you have a sum using the properties of the logs, you can write that as a product. That will become the log of 6 times 7, which is 42. And the base, of course, is 5. So then when properties of logs, if you have a base, 5, and then you have an exponent with a log, and the base of the log is also 5, 5 here, the answer is whatever you're taking the log of, which is 42. So the answer to this is 42. Okay, the next one, a little bit more involved than this one here, but here make sure we have this clear. This is e, and then this is the log, and the base for that log is e squared, just in case it's not clear. It's e, it's a log of 16, and the base here is e squared. Okay, now had that just been a plain old e instead of e squared, then that log to base e would just be ln. The answer would just be 16. Okay? In other words, if you have a to a power of log of, say, x to base a, if this base here and this base here are the same, then the answer is whatever you're taking the log of. In this case, it's x. That's the property of logs. But it's not that. It's e squared there. But just using some basic algebra, we can fix that. And let's do this. This is equal to, write a little bit bigger here, e, and this is the log, and the base is e squared. And then 16, I'm going to write it as 4 squared. Now, why did I do that? Because I need to simplify this without using the calculator. And the only thing I can use is the laws of the properties. So now I can do this. I have the log, and this base is e squared of 4 squared. There's a property that allows you to bring this exponent as a coefficient. So we write this. This will be 2. And this will be the log. Base is still e squared. And because I brought the exponent as a coefficient, this is just 4 here. And now we should know the answer, but just so you make it clear to you, let me write this as e squared. This is the same thing, just another view of this. I'm going to write this as log base e squared 4. Now can you tell me the answer? Well, see, now here the base is e squared, the way I have it. Because remember, this way you use the property of exponents power to a power, so I multiply the log of 4 to base e squared times the 2, and I still get the same thing that I had over here. Those are the same. But you can see here that this is e squared and this is e squared, so based on the property of logs, the answer is just whatever this number is here. So that's 4. Thanks for watching. We'll see you next time.